Hey everyone, and welcome back to the channel. Today, we are blasting off on an epic journey to debunk some of the most common and fascinating myths about our solar system. You might think you know the sun, the moon, and the planets, but trust me, what you are about to hear will definitely make you look up at the night sky with new eyes. We're talking about cosmic revelations that will blow your mind, so buckle up. First up, let's talk about our incredible star, the sun. We often picture it as a perfectly still, glowing orb, right? Well, prepare to have your mind gently twisted. The sun isn't fixed. It actually rotates on its axis, much like Earth does. But here's the kicker. It doesn't rotate uniformly. Imagine trying to spin a giant ball of jelly. Different parts would move at different speeds. That's essentially what our sun does. It spins faster at its equator, completing a rotation in about 25 Earth days, while its poles take a more leisurely 35 days. This isn't just a quirky fact. This differential rotation is a fundamental process that shapes the sun's powerful magnetic field, which, as we'll discuss later, has huge implications for our entire solar system. So, the sun isn't just a fiery ball, it's a dynamic, spinning, celestial dancer. Next, let's turn our gaze to our closest celestial neighbor, the moon. How many of you have heard that the moon's phases are caused by the Earth's shadow covering it? It's a super common misconception, and honestly, it makes sense if you don't dig deeper. But here's the real story. The moon's phases are all about geometry and perspective. The moon is always half illuminated by the sun, just like Earth. What we see as different phases, new moon, crescent, quarter, full moon, is simply the changing angle of sunlight hitting the moon as it orbits our planet. As the moon moves around Earth, we see more or less of its sunlit side. Think of it like this. If you walk around a soccer ball with a flashlight shining on it from one side, the amount of illuminated surface you see changes with your position. The Earth's shadow only comes into play during a lunar eclipse, when our planet briefly blocks the sun's light from reaching the moon. Otherwise, it's all about that beautiful cosmic dance between sun, Earth, and moon. Speaking of the moon, here's another fun fact that often gets overlooked. The moon actually rotates. Many people mistakenly believe it doesn't because we always see the same side of it from Earth. This phenomenon is called tidal locking. The moon does rotate on its axis, but its rotation period perfectly matches its orbital period around Earth. It takes the moon about 27.3 days to complete one rotation on its axis, and it also takes roughly 27.3 days to complete one orbit around Earth. This synchronous rotation means that while the moon is spinning, it's also constantly moving around us, so we only ever get to see that familiar face. It's not that the moon isn't rotating, it's just doing it in perfect harmony with its orbit, a beautiful cosmic ballet orchestrated by gravity. So next time you look at the moon, remember it's not a static object. It's a spinning world, just like ours. And while we're on the topic of our moon, let's tackle a myth that pops up surprisingly often, that the moon's phases, especially a full moon, somehow influence human behavior. You've probably heard tales of increased crime rates, more births, or people acting a little crazier during a full moon. It's a compelling story, often rooted in folklore and ancient beliefs, and it even has a fancy name, the lunar effect. However, when scientists have actually looked into this with rigorous studies, the evidence just isn't there. Researchers have analyzed countless data sets on everything from hospital admissions to crime statistics and found no statistically significant correlation between the moon's phases and human behavior. While the moon's gravity certainly affects our tides, its gravitational pull on a small human body is utterly negligible. Our emotions and actions are complex, influenced by countless factors, but the moon's phase isn't one of them. So, the next time someone blames the full moon for their bad mood, you can politely inform them that science says otherwise. Alright, let's venture a little further out into our solar system, past Mars, to the famous Asteroid Belt. When we see it depicted in movies or video games, it's often shown as this incredibly dense, chaotic minefield where spaceships have to navigate carefully to avoid constant collisions. It makes for great drama, but it's not quite accurate. The truth is, the asteroid belt is incredibly sparse. While it contains millions of asteroids, the sheer volume of space within the belt is enormous. If you were piloting a spaceship through it, you'd find that objects are separated by hundreds of thousands, even millions of miles. Imagine trying to hit a tiny pebble with another tiny pebble from miles away. That's the scale we're talking about. Collisions certainly happen over billions of years, but on a human timescale, the asteroid belt is a remarkably empty place. So, No need to fear a cosmic bumper car ride if you ever get to visit. Now, let's zoom out to the majestic gas giants. When we think of rings, one planet immediately comes to mind, right? Saturn, with its absolutely stunning, iconic ring system. And while Saturn's rings are undeniably the most famous and spectacular, it's a common misconception that it's the only planet with rings. Surprise! Jupiter, Uranus, and Neptune also have ring systems. They're just not as bright, wide, or easily visible as Saturn's. Jupiter's rings are faint and made mostly of dust kicked up from its small inner moons. Uranus's rings are dark, narrow, and made of larger, darker particles, discovered only when the Voyager 2 spacecraft flew by. Neptune also has faint, clumpy rings, famously featuring arcs where the ring material is denser. So, while Saturn is definitely the ring king, it's not the sole possessor of these celestial hula hoops. All four gas giants proudly sport their own unique sets of rings. And speaking of Saturn's rings, let's clarify another big myth, that they are solid. They look so uniform and smooth from a distance, like a giant, solid disk, but that couldn't be further from the truth. Saturn's rings are not solid at all. They are composed of billions, if not trillions, of individual particles. These particles range in size from tiny dust grains, smaller than a grain of sand, to boulders the size of houses, all orbiting Saturn independently. Each little piece acts like its own miniature moon, following Kepler's laws of planetary motion, with inner particles orbiting faster than outer ones. Imagine an enormous cosmic highway with countless individual cars all driving in perfect formation, but each car is separate. It's an incredible dance of ice and rock, sculpted by gravity and the occasional collision, constantly rearranging itself into the intricate patterns we see. So, next time you admire Saturn's rings, remember it's a beautiful cosmic swarm, not a giant frisbee. Let's circle back to our sun for a moment. Earlier, we talked about its differential rotation. Well, that spinning action isn't just a cool party trick. It's absolutely crucial for our entire solar system. The differential rotation of the sun, combined with convection currents within its interior, generates its powerful magnetic field. This field extends far beyond the visible surface of the sun, creating what's called the heliosphere. Think of the heliosphere as a giant magnetic bubble that encompasses our entire solar system. This bubble acts as a protective shield, deflecting harmful cosmic rays and interstellar particles that would otherwise bombard our planets. Without the sun's differential rotation creating this magnetic field, Earth and all the other planets would be constantly exposed to much higher levels of dangerous radiation, making life as we know it potentially impossible. So, that quirky spinning motion of the sun is literally keeping us safe. And finally, let's address another common misunderstanding about the moon and its gravitational effects here on Earth. We all know the moon's gravity causes ocean tides, pulling the water towards it. This fact sometimes leads people to believe that the moon's gravity might also have a significant effect on our bodies, since we're mostly water. However, while the moon's gravity certainly influences large bodies of water like oceans, its effect on a small human body is utterly negligible. Tidal forces depend not just on the strength of gravity, but also on the difference in gravitational pull across a body. For an ocean, the difference in pull between the side of Earth facing the moon and the side opposite is significant enough to cause bulges of water. For your body, which is tiny compared to an ocean, that difference in gravitational pull across your few feet of height is practically zero. You're far more affected by the gravitational pull of a nearby building, or even a person standing next to you, than by the moon's minuscule tidal force on your individual cells. So rest assured, the moon isn't subtly tugging at your internal fluids. Before we wrap up, let's quickly revisit Saturn's rings. We talked about how they're not solid and how all gas giants have rings. But why are Saturn's so uniquely bright and visible compared to the others? It's all about reflectivity. Saturn's rings are exceptionally bright because they are made mostly of highly reflective water ice. Imagine countless tiny mirrors orbiting the planet, catching and scattering sunlight back towards us. Jupiter's rings are darker because they're made of dust. Uranus and Neptune's rings are also darker, composed of more rocky, carbonaceous material that absorbs light rather than reflecting it. This icy composition of Saturn's rings not only makes them stunningly beautiful but also a source of intense scientific study, as researchers try to understand their origin and evolution. It's truly a marvel of the cosmos. And there you have it, folks. 10 incredible facts that might just change the way you see our solar system. From the sun's differential spin protecting us all to the moon's hidden rotation and its true influence or lack thereof on us. And the surprisingly empty asteroid belt to the secret rings of Jupiter and the icy marvels of Saturn. Space is full of wonders, and often, the truth is even more mind-blowing than the myths. I hope you enjoyed this cosmic debunking journey. If you learned something new or found any of these facts particularly surprising, please let me know in the comments below. Which myth was your favorite to bust? Don't forget to hit that like button, share this video with your fellow space enthusiasts, and if you haven't already, subscribe to the channel for more exciting journeys through the universe. Thanks so much for watching, and I'll catch you in the next one.